Hi students, in this video we're going to take a closer look at how we evaluate arguments, and in particular how we evaluate the validity of an argument. So let's get started. We learned last time that a valid argument is an argument where the truth of its premises guarantees the truth of its conclusion. So an argument, you'll remember, right? Just reasons given in favor of some conclusion. We often put those arguments in standard form. A valid argument is one that has the right kind of structure, where the truth of the premises guarantee the truth of the conclusion. Here's a classic example of a valid argument. Socrates is a man, all men are mortal, therefore Socrates is mortal. That argument is valid because if the premises are true, as if Socrates is a man, and if all men are mortal, those two things are true, then it follows that Socrates must be mortal as well. You'll also remember from last time that an argument needs to be valid in order to be sound, right? If an argument's not valid, then it's not sound. Now, whether an argument is valid depends on the structure. In our class, we'll evaluate the validity of arguments by seeing whether those arguments take valid argument forms. So what are some valid argument forms? As you'll remember from last time, a valid argument form is an argument form where any argument that takes that form or that structure is going to be valid. So here's an example, right? If O and U is in Ada, then O and U is in Ohio. O and U is in Ada. Can we infer anything from those premises? Yes. If we don't know anything else in the world, if the only things we know are that if O and U is in Ada, then it's in Ohio, and we know that O and U is in Ada, we know some further thing. We know that O and U is in Ohio. Again, whether or not these claims are true is irrelevant. It's just that structure. If it's true that being in Ada guarantees being in Ohio, and if it's true that O and U is in Ada, then we can know some further thing that O and U is in Ohio. Now the form of this particular argument is modus ponens. We're going to symbolize it MP. And when we look at how we might symbolize the argument as a whole, we can give a few different, there are a few different ways to symbolize it. So the first one, we're going to sort of look at these separately. The first one on the left over here, right? Notice that there's this if-then claim. It's a conditional claim. If A, O and U is in Ada, I'm going to symbolize that proposition, O and U is in Ada, with just an A. Then O and U is in Ohio, then O. Now, when we go to symbolize the second premise, we're just going to say A, because as you'll notice, right, if O and U is in Ada, that's what got an A above, so we're going to give that an A again, right here. There's no if-then, so just simply A. Conclusion, I often write therefore, thus, something like that, just to suggest, right, another clue that this is a conclusion. It follows from the premises. O and U is in Ohio. Now that proposition, right, matches the proposition that came after the then up here. So that proposition that got symbolized O earlier, this is the same thing, so we're going to write that as O. One way we might simplify things a bit is by, rather than writing if A then O, we could just write A arrow O. And that's to indicate that there's the if-then claim is stating a certain kind of relationship between A and O. It's saying that whenever A is true, O is true. If we looked at what are called necessary and sufficient conditions, we'd see that A is sufficient for O, A guarantees O is necessary for A. That's, whenever that's the case, we have this A arrow O relationship. Premise 2 again is just A, it's just stating A is true. So if A is true, then O is true, A is true, therefore we know that O is true. That's one way we might symbolize this particular argument. But over here what I've done is I've just said if A then B, A, therefore B. And this could be I'm not using A and B to symbolize anything in particular. There's this sort of coincidence that I think symbolizing O and U's in Ada is easy to symbolize as A. O and U's in Ohio is maybe naturally symbolized as O. But anytime any argument, say it was like B arrow D, B, therefore D, what's important is that it has the structure. If something, then something else. That first thing is true. Whenever we know these two things, we can infer the conclusion. And the order of the premises doesn't matter too much here. It's not really important. So if premise 1, for example, was A, premise 2 is A arrow B, that would still be modus ponens, right? As long as the conclusion is B, right? We could still get that. Here's a valid argument that takes a different form, right? Let's say you know this. If O and U is in Ada, then O and U is in Ohio. Let's say you also know that O and U is not in Ohio. Can we know anything else? Yes, we can. What is that thing we can know? If O and U is in Ada, then it's in Ohio. We know O and U is not in Ohio. So it must not be in Ada. Therefore, O and U is not in Ada. The form of this argument is modus tollens, or MT, and can be symbolized as follows. So again, I've given you a few different options over here, right? If A, O and U is in Ada, then O and U is in Ohio. But O and U is not in Ohio, right? It's not the case that O is true, O is false, right? It's going to be symbolized with this little squiggly called a tilde, T-I-L-D-E. Tilde O, not the case that O, therefore it's not the case that A. If we go over here, maybe symbolize things a little bit more, right? We take out the words, if then the conditional, right? Just A arrow O. O and U, if O and U is in Ada, then O and U is Ohio. Comes after the if is the antecedent, comes after the then is the consequent. If we know that being in Ada guarantees being in Ohio, and we know that O and U is not in Ohio, then we can know that it's not in Ada either. Again, maybe if we generalize that even more, we might say, well, this is just generally has a structure. If A, then B, the consequent is false. Whatever's over here on the right side of the arrow, right, is not true. Therefore, whatever's on the left side of the arrow is not true. That's modus tollens structure. One final valid argument form. If O and U is in Ada, then O and U is in Ohio. If O and U is in Ohio, then O and U is in the US. What can we infer from these facts? We can infer that if O and U is in Ada, then O and U is in the US. This is by this transitive property, right? If one thing has a relationship to this other thing, and that other thing has the same relationship to the third thing, then the first thing has that relationship to the third thing. You don't need to know that. It's not that important. But we see this with height, for example. So if John is taller than a chair, and a chair is taller than a mouse, then John is taller than a mouse, something like that. The form of this argument is hypothetical syllogism, or HS, and it can be symbolized in the following way, right? If A, then O, if O, then U, therefore, if A, then U. If we, again, take the words out and just use symbols, A guarantees O, A arrow O being Ohio guarantees being the US, therefore we can know that being in Ada guarantees being in the US. And this, again, is just another example of this more general form, if A then B, B then C, therefore if A then C. Those are our valid argument forms. We've seen 3 of them. There are more. Disjunctive syllogism is a common one that we won't really be studying But you could look up, right, if you're interested. Now, it's important to note that the order of the premises doesn't matter. I think I've mentioned that before, right? Whether you get A arrow B first and then A, or you could have A first and then A arrow B on the second line, that doesn't matter. But it doesn't mean that anything goes, right? We can't just have like a bunch of A's and B's mixed up in whatever order we want and have a valid argument. Right? If B were up here, we wouldn't have a valid argument. If not A were up here as a premise, we couldn't conclude that not B. So here are some common invalid forms: affirming the consequent and denying the antecedent. Right? This is called affirming the consequent because we've got a conditional claim. Notice that all our arguments have a conditional claim. A guarantees B. We know B. It's tempting to infer A, but this is actually an invalid argument. We can't do that. We don't want our arguments to take that form. And if an argument does take that form, we know there's a problem with it. It's invalid. Same over here. If A, then B. If we know that not A is true, we can't infer that not B. Again, this is an invalid form. It's going to be tempting. It looks kind of good, but it actually is not a good argument form. So we're going to look at some examples to illustrate that. All right, evaluating argument forms, now we're going to look at some invalid forms. Consider this argument. If John lives in Ada, then John lives in Ohio. John lives in Ohio. What is it tempting to infer? It's tempting to infer that John lives in Ada. But do these premises guarantee the conclusion? No. Why not? Well, let's take a look at a map, right? If John lives in Ada, then John lives in Ohio. Yep, if John lives here in this star, then John lives in this bigger place, Ohio. Let's say we know that John does live in this bigger place. Can we know that John lives in the star? No, we can't. Even if it's true that living in Ada guarantees living in Ohio, and it's true that John lives somewhere in Ohio, we can't conclude that John lives in the star, because John could live in Cleveland, Columbus, Cincinnati, etc. And as a matter of fact, right, I don't live in Ada. I live in Bluffton. So that argument is invalid. What's important to note is that what makes it invalid isn't that I don't live in Ada, right? Even if I did live in Ada, the argument would still be invalid. It would be still a bad argument, and that's because the truth of the premises don't guarantee the truth of the conclusion. So if you were trying to convince someone that I lived in Ada or Bluffton, you're trying to convince someone that I live in Ada, let's say I do, right? But you give them this argument, they shouldn't believe you because it's a bad argument. But here's another argument, right? Growing up, I had a friend named Pat. Say I give you this argument about Pat. Say if Pat is a bachelor, then Pat is unmarried. Say Pat is unmarried. It's tempting to conclude what? Tempting to conclude that Pat is a bachelor. Why don't the premises guarantee the conclusion? What's wrong here? Well, what's wrong is that Pat isn't, even though it might be true that if Pat's the bachelor, then Pat's unmarried, and it might be true that Pat's unmarried, it could still be possible that Pat is not a bachelor. So it's possible for the premises to be true, but the conclusion to be false. So if we're trying to come up with counterexamples to show how it could possibly be true, premise 1 and premise 2 are true, but the conclusion's false, come up with some counterexamples. Who would Pat have to be in order to make the premises true and the conclusion false? Now this is worth thinking about a little bit, right? So this might be an exercise you can try, pause it, think about how to make the premises true and the conclusion false. We need it to be true that if Pat's a bachelor, then Pat's unmarried. That's actually easy, right? That's guaranteed. It's got to be true. All bachelors are unmarried. Now, the trickier thing is we need Pat to be unmarried, but Pat not to be a bachelor. So how are we going to do that? One way we could make Pat baby, right? In this case, Pat's unmarried, but it's not really right to say that Pat is a bachelor, right? If this is Pat, it'd be wrong to say, well, Pat's an eligible bachelor. No, because he's not really of marrying age. Another option, right? Maybe Pat's a woman. So that would make the premises true, but we would not say, if this is Pat, right? We would not say Pat's a bachelor. Another option, right? Maybe Pat is a priest. Maybe he's the Pope. Might be a man, might be an adult man, but we wouldn't say that a priest was a bachelor, right? They're not eligible for marriage, so bachelor wouldn't apply. Some other examples, maybe Pat has been married in the past. Maybe Pat's dead. I think people have suggested that. There might be a number of different ways to make the premises true and the conclusion false. So again, even if the premises are true, C1 could be false, Pat could be a baby, a woman, a priest, etc. And what I've shown is that this structure of argument, right, it doesn't guarantee the truth of the conclusion. So arguments that take this form aren't going to be valid. Now the two previous arguments took the form affirming the consequent, which can be symbolized like this. If A, then B, B, therefore A, or, symbolize more clearly, taking the words out, A, then B, B, therefore A. We call this affirming the consequent because the premise that's not a conditional statement affirms the consequent of the conditional. So you'll remember from the past, when we've got a conditional, like A, arrow B, the first term is called the antecedent, the second term is called the consequent, and in an argument like this, we get another premise, that says if A then B, it affirms the consequent. It says that consequent is true, but we can't know from that that the antecedent's true. So that argument's invalid. Here's another one. Consider this. If John lives in Ada, then John lives in Ohio. John does not live in Ada. It's tempting to conclude John does not live in Ohio. One of the premises guarantee the conclusion. Again, we can think back to our image of Ohio. If John lives in Ada, he lives in Ohio. That's true. Say John does not live in Ada. He doesn't live here. Can we infer that John doesn't live in Ohio? Maybe he's over in Michigan, Indiana, Kentucky? No. Because John could live somewhere else in Ohio, just not in Ada, right? He live in Bluffton, as is the case. So even if these premises are true, the conclusion could be false. John could live in one of these other places, and that shows, right, that this structure of argument is not a valid structure. You can give another example, right? If John's favorite food is an apple, then it's a piece of fruit. His favorite food is a piece of fruit. John's favorite food is not an apple. Therefore, John's favorite food is not a piece of fruit. Well, these premises guarantee the conclusion. Well, let's say John's favorite food is, if it's an apple, then it's a piece of fruit, right? That's true. And let's say that John's favorite food is not an apple. How can we, is it possible for these premises to be true, but the conclusion be false? John's favorite food is a piece of fruit? Yeah, we just need to come up with an example where John's favorite food is a fruit, just not an apple. So what are our options, right? Oranges, strawberries, bananas. In all these cases, even if the premises are true, the conclusion could be false. John's favorite food could be oranges, strawberries, bananas, etc. The previous two arguments took this form denying the antecedent, which is symbolized like this. If A, then B, but not A, therefore not B. If A, then B, not A, therefore not B. in this case, what we're doing, again, how it gets its name, denying the antecedent, the premise that isn't a conditional, premise 2, denies the antecedent of the conditional statement. So if A then B, not A, we're saying not the case that the antecedent is true. It's not the case that the antecedent is true, concluding that the consequent is not true either. But as those examples showed, just like arguments that take this form aren't necessarily valid. Just because these premises are true doesn't guarantee that this conclusion is true. So those are invalid argument forms. We want to avoid those if we can. Alright, so that leaves us with 3 valid argument forms: modus ponens, modus tollens, hypothetical syllogism. All important, all going to be argument forms that are common and used with some frequency in our course. And there are these 2 invalid argument forms. And when it comes time for you to construct arguments, you want to make sure that you're not constructing arguments that take these forms. And the worksheets and the work that we'll be doing will have some arguments that take these forms, trying to trick you into thinking that they're valid. You want to be able to identify that they're not. Of course, it's also important to remember that there are other valid and invalid forms that we haven't discussed. So like I said, there are some other valid argument forms, but there are also some, an infinite number of invalid argument forms potentially. And so just because an argument doesn't take one of the forms here doesn't mean that it's couldn't be valid, that it couldn't be invalid. For our purposes on the questions, I'm not going to give you a valid argument that doesn't take one of these 3 valid forms, but I might give you an invalid argument that doesn't take one of the invalid forms. All right, that's all for valid and invalid argument forms. We'll be back later with more logic.